So in part B, we're going to explain why the function is differentiable at the point, then find the linearization L of xy of the function at that point. Okay. So part B, we have f of xy equals e to the x sine xy, and we're talking about the point 0, 3. So why might it be differentiable at that point? There's a theorem that guarantees us that it's actually differentiable. Well, the partials have to be continuous. That's what the theorem says. If you can guarantee that the partials s of x, f sub y are continuous, got to be on the domain, right? Then, or at 0, 3, then you're guaranteed that f is differentiable at 0, 3. So let's take the partials and just make the observation that the partials are going to be continuous there, because they're going to be products of an exponential function and a trig function. And those are continuous. Products of continuous functions are continuous. So it's just we're just going to make the observation. It's not going to be a big deal. And then finding the linearization, it's really just finding the equation of the tangent line, or tangent plane rather, at the point 0, 3, right? Yeah. So as with almost any problem in this chapter, take the partials if you don't know what to do, and you'll get partial credit. Okay, what's the part? Oh, what do we have to do here? Product rule. Oh, I'm feeling too lazy to do the product rule today. Okay, so the derivative of the first, so this is the partial with respect to x. So we think of y as just a regular constant. X is the variable. So the first function is the exponential function e to the x. The second function is sine of xy. We take the product rule says take the derivative of the first, but that's just e to the x, right? Times the second function, which is sine xy. Plus the first, e to the xy, times the derivative of the second. What's the derivative of sine xy, sine of xy with respect to x? Yeah, because of the chain rule, you're going to have an extra factor of y out front, aren't you? So y cosine xy. And that's because you take the derivative of the sine of xy as usual, get the cosine of xy, but then the derivative of x times y with respect to x is y. So you have, by the regular calculus 1 chain rule, you have this extra factor of y. That would be the constant with respect to x there in that inner function. So you have that factor of y out front. Yeah. So that's f sub x. What about f sub y? Do we need to use the product rule there? No, because there's just one y, right? One function of y there. So what's the derivative of e to the x sine xy with respect to y? Yeah, so e to the x, is it sine? Cosine xy, and then by the regular calc 1 chain rule, if you take, this is the inner function. If you take the derivative of that with respect to y, you get an x. You could put it out front if you want, like that. Does that seem reasonable to you? Now, what do we actually need to do with both of these? Well, we'll make the observation that this is continuous. Both of these guys are continuous everywhere. No, so I'll just say this. Note, both the partial with respect to x and the partial with respect to y are continuous for all xy. I'm not done. Hold on just a second. So why are they continuous? Well, okay. The sum and product of continuous functions, which these guys are, if you look, these guys are both the sum. Well, this guy's just the product of continuous functions. This guy involves a sum. The sum and product of continuous functions is continuous. You learn about that in Calc 1. So that's my explanation. Now, what are the functions we're talking about? Well, okay, I'm going to erase this in a second. This is something we're not going to worry about. E to the x is continuous for all x. Sine of whatever the input is, xy in this case, well, xy is continuous, right? X times y is continuous. So if you insert that into the sine function, another continuous function, it's also a composition, right? So I should say sum and product and composition. If you want to be picky here. Continuous functions is continuous. So e to the x is continuous. Sine of x, y is continuous. What else do we have? Y by itself, right? A factor of y is continuous. Cosine of x times y is continuous. So it's not, did I miss anything? It's a non-issue, right? If you take a product or a sum or a composition of continuous functions, you get a continuous function. So then what does that mean? So by the theorem from, I guess it was 14.4, the last theorem we talked about, since the partials are both continuous, f is differentiable. So f is differentiable. So we want to find the equation of the tangent plane, and write it down. Z minus z naught is equal to the partial with respect to x evaluated at the point of the x and y value that generate the point of tangency, x naught, y naught, times x minus x naught, plus the partial with respect to y evaluated at x naught, y naught, times y minus y naught. And then to get the linearization, all we do is move the z to the other side. So if you wanted to do it right away, the z naught, that is. And then that z, that thing on the left, that is what we change the name of that to L of x, y, right? So you fill this in and you have your linearization. Okay. Well, what does that mean we have to do with the partials? Well, we have to evaluate them at the point, at the x and y values that produce the point of tangency on the surface, right? So what are those what's x naught, what's y naught in this case? 0 and 3. Okay. So what do we get for f sub x evaluated at 0, 3? So focus your eyes on this guy. Well, I mean, the first term just devolves to 0, doesn't it? Because you end up taking the sine of, 0 times 3, which is sine of 0, which is 0. So that whole part is 0. So 0 plus what? Okay, you end up taking the cosine of 0, x times y is 0, x naught times y naught is 0, right? But the cosine of 0 is actually 1. Oh, but you have but y is 3, right? X is 0. So what's that going to be then? 3. Does everybody see that? E to the 0 is 1, and then you have times 3 out here times another 1. Does everybody see that? Okay. So just 3. And then the partial with respect to y evaluated at 0, 3. That'll be easier. Just focus your eyes on this guy. What is that going to be? 0. So x is 0. You plug 0 in there. Yep, you get 0. Okay. And then I'm just going to plug into basically the equation of the tangent plane. So what's L of x, y going to equal? So just 3 times x minus x naught. But x naught was 0, right? So 3x. And then was this part was 0, so we don't need to add anything there, do we? So that's it.